Hello students, a good day to you. How are you doing today? This video is on mensuration. We already started with the first part where we focused majorly on polygons majorly, spoke on perimeters of squares, of triangles, of rectangles, of trapezium, and the rest of them like that. And we have been able to treat that quite effectively. So we want to move a little bit forward by looking at circles. All right, so our mensuration today will be focused majorly on circles, and this video is for grade 10 students, and I say that you are welcome. Now, our objective for today's video is that at the end of this video you should be able to identify the different parts of a circle. You should be able to recall and apply the formula for the circumference and area of a circle, which I believe that you're quite familiar with. And last but not the least, you should be able to recall and apply the formula for the length of an arc, for the area of a sector, and for the area of a segment, which for a number of you it might be relatively new, but at the end of this video you would be expected to be able to meet all these three objectives that we have for this video. So let's begin by finding out what a circle is. Now, I'm sure that you all know what a circle looks like, but if you are to define a circle, you might have a challenge being able to put what you can recognize into words that would make mathematical sense. So a circle is a shape wherein all points have the same distance from a fixed location. A circle is a shape where all the points have the same distance from a fixed location, and that's simple enough. But what if you want to bring in a little bit of mathematical language? Then you could define a circle as a set of all points which are equidistant from a fixed point. Now, equidistant means that they are of equal distance from a particular fixed point. Now, that fixed point is what you call the center of the circle. And then the distance from the center of the circle to the point of the circle, which of course would be called the circumference, the distance between that center and that circumference, which is the points that form the circle, is called the radius of the circle. I want to believe that this is not new to you, because to a large degree you are quite familiar with circles and at least some of the parts of a circle, especially parts like radius and center of a circle. But don't forget that all points of a circle are equidistant from the midpoint, which is called the center of that circle. And you have circles all around us. I mean, examples in real life, you have wheels, you have the wheel of your vehicle and things like that, your plate. A lot of plates are also circular. You have coin and a few other things like that. I'm sure you have an idea what I'm talking about. If you look around you, wherever you are right now, you are probably going to see things around you that are circular in shape. Okay, and this is what a circle looks like, and you can see the radius right here from the midpoint, which is the center of the circle, which is O right here. And you see the line from that point up till the body of the circle, which of course is called the circumference. You can see that line right there that is labeled R, and R means radius. And like we said, that every point on the circle has the same distance from the center of the circle. So it's possible for me to draw this line, okay? And if I drew this line, you would find out that it is exactly the same length as the original line right here, because every line from the center of the circle to the circumference of the circle is equal in length. That would be the radius. Okay, so I could draw another one right here, and it will be exactly the same length as the first two. I could draw another one right here, and it will be exactly the same length as the first three. And I could just go on and on. I could go round the circle over and over again, and every single time I'll have the same length from the center to the body of the circle, which is called the circumference. And that brings something to mind. That gives us a conclusion, because now it is obvious that the radius of a circle is the same no matter the direction in which it is drawn. So it doesn't matter if you draw it this way or this way or this way, as long as it is a line from the center of the circle to the circumference of the circle, then it will be the same length all around. Okay, and you could try that out. You could do that as an activity if you do have the time to do that. All right, so let's step a little bit forward and look at important terms that are related to circles. Or we'll be talking about the parts of a circle right here. And this is a picture right here on your screen of some of the major parts of your circle. You can see different lines and their different names. So we're going to see how we can mention a few of these parts, so that in case you come across questions where any of those parts are named, you know exactly what is required of you, in that kind of a question. All right, so the first part of a circle that we will mention is the diameter. Now you can see the diameter in green right here. You can see from this point right here at the body or circumference of the circle down to the other side, and it passes through the center. That is what is called the diameter. So the diameter is a line which is drawn across a circle passing through the center. So every time that you draw a line from one part of the circle to another part of the circle passing through the center of the circle, that line is called a diameter. Okay, so if a question tells you that diameter of a circle is so and so, then you know exactly what that question is referring to. The next one will be the radius. You can see the radius right here. We already mentioned that the radius is a line from the center of the circle to any part of the body or circumference of the circle. So it's the distance from the middle of a circle towards any point on the circle. That's what is called the radius. And you can see right here that the radius, if you had two of them set in front of each other, will form the diameter. You can see right here from the center, if you look at this green diameter, from the center right here to this part would be one radius, and then from the center right here to the other part will also be another radius. So it means that the diameter is 2 times the radius. Okay, 2 times the radius will give you the diameter. All right, also we have the chord. And the chord is a line segment that joins 2 points that are present on a curve. A chord is a line that joins 2 points that are present on a curve. So if you have a line that joins 2 points, like from here right now to this other part of the circle, without passing through the center of the circle, then that line is a chord. Now, if this line passed through the center of the circle, it will be a diameter. But now it didn't pass through the center, so it is a chord. It's called a chord. If you have a line from one part of the circumference to another part of the circumference without passing through the center, then that line is called a chord. Okay? And then we also have the tangent and the arc. I decided to put this together, well, because I decided to put it together. Now, the tangent is a line which touches the circle only at one point. So it's a line that touches the circle on its travel to a different direction. So the tangent just touches the circle. It does not cut through the circle. It just touches it. Okay, and if you see this line right here, it just touches the circle at this point. and that is what is called the tangent. Whereas the arc is a part of the circumference of a circle. If you look at this part right here, the entire length of the circle forms the circumference, but this part right here is what is called the arc of the circle. Just a part of the circumference of the circle is what is called the arc. Okay, and this is really important because on a lot of occasions you're going to be dealing with questions that have to deal with arcs and tangents and chords, a number of stuff like that. The next one will be a sector and segment, and putting them together once again because I chose two. A sector, you can see right here, this is a sector, and if you would describe this, it is the space between two radii of a circle that are connected to an arc of the circle. You can see these radius right here from the center to the circumference, and then these other radius from the center to the circumference connected with these arc right here, and that forms a sector. And it's important to understand this. A sector is formed by two radii and one arc, whereas a segment, on the other hand, is a region that is formed by a chord and an arc. You can see this chord right here that joins the circumference here to the circumference here, and then combined with this arc that forms your segment. So whereas a segment is formed by a chord, your sector is formed by two radii. All right, that difference is really very important for you to keep in mind. Okay, so next we will go to circle formulas, which is bringing us into the middle of what we really do have to do today. Circle formulas. Now, there is a relationship between all circles, and it is such that the circumference of a circle divided by the diameter of the circle always have the same ratio. That is, the size of the circle and the length of the line that will connect one part to the other part passing through the center will always be the same ratio. So if you have a small circle, obviously you would have a small diameter compared to if you have a larger circle, which of course will give you a larger diameter. So every time that you divide the circumference of a circle by the diameter of the circle, you get exactly the same ratio, and this ratio is what is called pi. I'm sure you know that number. Pi is from the Greek alphabet, is the 16th letter, and it is an irrational number, and the symbol is what you have on your screen. So it means that your circumference divided by your diameter of a circle will give you pi, which is of course 3.14, and it goes on 19. It goes on like that. It's an irrational number. I'm sure you're familiar with that. Most of the time you will use maybe a 2 decimal place pi, okay, 3.14 or 3.142, depending on whatever it is that you are given to do or use. Okay, so now from here it's easy to see that the circumference of the circle will be equal to, if you cross multiply right here, you would get pi d. You remember that your diameter is 2 times the radius. So if we decide to use the radius, then that'll be 2r times pi. That's what gives us this formula for the circumference of a circle. I'm sure you are very familiar with this formula. It is used to measure the circumference of a circle. Rather than use the word perimeter in a circle, circumference is used, and you have 2 pi r. So the formula for calculating the circumference of a circle is 2 pi r. It was gotten from this particular ratio right here. If you cross multiply, you have pi d. So sometimes you could use pi d to get the value for your circumference. It's basically the same thing. And then of course the area of a circle is pi r squared. I'm sure you're familiar with that. But what about when we want to look at the length of an arc? Now we already said an arc is, look, if you look at this diagram, you can see this arc right here in red. The arc is a portion of the circumference of a circle. Okay, so now if you have an arc like this that subtends an angle at the middle, you can see that angle right here, theta. Of course, this is a radii. Of course, this is a radii. Remember, the radius of a circle would be equal in any direction that you draw the line. Okay, so this radii here is radius here is the same value as this radius here, and then it subtends an angle theta in the middle of the circle, and you have an arc right there. Okay, now the entire circumference of the circle, if you go around the circle like this, you have 2 pi r. We already established that up there. It's 2 pi r. But then if you decided to cut a portion of this circle, now the value of the length will be determined by the angle that you cut out. Okay, what I'm trying to say is that if you cut a portion like this, if you can find the ratio of this portion compared to the entire circle, then it will give you the ratio of the length of this arc compared to the entire length of the circle. I hope you understand that. Okay, so this angle in the middle is quite important. And you remember that if you found the circumference of the entire circle, that would be 2 pi r. But the angle at the middle will be 360. What if I cut a certain part of that, and we call that part theta? So the ratio of the part that I have cut off compared to the entire circle would be theta divided by 360. Okay, because it was 360 before, and I cut this portion out. So I have cut out theta, and that would be theta divided by 360 off or multiplied by the circumference of the entire circle, which is 2 pi r. So the length of an arc is calculated by the formula theta over 360 degrees times 2 pi r. So every time that you are told to find the length of an arc, you just impute that formula and you are well on your way to get your answer. Okay, the next one would be the area of a sector. Now, we already said that a sector is the space that is carved out by 2 radii and 1 arc. So you can see the sector right here in your diagram. Of course, the sector, we're talking about the area, so it has to be a part or a fraction of the area of the circle. The area of the circle is pi r squared, and if I cut out this portion, which is theta, out of the entire portion, which is 360, then the formula for the area of a sector is easy to see as theta over 360 degrees times pi r squared. Okay, times pi r squared. So every time that you are asked to find the area of a sector, you only need to find the angle that it obtains at the middle. You insert that value, and then you press your calculator and get your answer. The last one that I have for you on these formulas for this video is the area of a segment. Now, we already said that a segment is the space that is carved out by a chord and an arc. So you can see right here, this portion that is shaded in the is the orange or whatever color it is. Anyways, this portion right here, okay, is the segment. And if you want to find the area of this segment right here, what you need to do is to find the area of this entire sector. You can see the sector OAB. You find the area of that entire sector, and then subtract the area of the triangle OAB from that. You understand? If you find this entire space and then you subtract this space right here, obviously what you would have left would be the area of the segment that is here. There are times that you will be required also to find the area of a segment, and all you need to do is to impute values into that formula, and you are well on your way. All right, so let's use these things in examples, a few examples, and see where that lands us. And we'll start with this example. Number 1, it says find the circumference and area of a circle which has a radius of 4 centimeters. And it says we should use the pi button on our calculators and give our answers correct to 2 decimal places. So here we are not to approximate by ourselves. Okay, we just let the calculator, approximate after it has exhausted all its digits for the pi. So we have to find the circumference. Obviously, we do know that the formula for the circumference of a circle is 2 pi r. So we insert values. That'll be 2 times pi, which we are not going to, impute a value for. The calculator will do that itself, times 4, which is the radius of this particular circle. And if you press your calculator, you get 25.1327, and it goes on and on like that. But then the question says we should give our answer to 2 decimal places, so we'll count 2 digits immediately after the decimal point, and we have 25.13 centimeters to 2 decimal places. It's important for us to make the examiner know that we approximated to 2 decimal places. Okay, so that's the first part. The second part asks us for the area of the circle. We know that the formula for the area of a circle is pi r squared. So once again, we insert values. Pi times r is 4, so we square that. Okay, and then we press our calculator. We'll get 50.265482, and then it goes on and on as well. Okay, and then we bring that to 2 decimal places, so we have 50.27 centimeters squared. Of course, that's to 2 decimal places as well. So it's important for you to put in the right units, okay, and make sure you use the right values. If a value is given to you for pi, make sure you use that value. And then if, like in this question, you're told to just use the pi button in your calculator, you do that exactly as you've been told. Now we'll go to example 2, and here we have a diagram on our screen, and the question says what is the length of the arc AB. So we have an arc right here, from A to B, and we have to find the length of that arc. Now of course we have these radii that from the center of the circle to A, and then from the center hole to B as well. And then the radius is 4 centimeters, like we can see right here. And the angle at the middle subtended by the arc is 120 degrees. So we know that the length of an arc is theta of 360 times 2 pi r. Okay, so we'll insert values into that. Our theta is 120 degrees, so we divide that by 360 and impute values, and when we press our calculator we get 8.37758, and it goes on and on. In this question we're not particularly told what approximation to use, so most of the time I just use 1 decimal place. So you have 8.4 centimeters to 1 decimal place. And why is it centimeters? Well, because they're asking us for the length of the arc. Length is always in centimeter or meter or kilometer. I'm sure you know that. Okay, we're not trying to find the area, but the the length of that arc right there. So that's fairly easy, and from there we proceed. Excuse me. We have to find the radius of the following circle. We have to find the radius of the circle that is on our screen. So we have the length of the arc, you can see right there, is 3 centimeters. We have a 3 centimeter arc, we have a 60-degree angle, we have a radius here, but we don't know the value of the radius. So once again we impute the formula. The length of an arc is theta over 360 times 2 pi r. In this case the length is 3, so that would be equal to 60, which is the angle in the middle, divided by 360 times 2 pi r. And then we cross multiply. Here you have 60 by 2, so you have 120 pi r is equal to 3 times 360, and then you divide both sides by 120 pi, and the final answer for our r will be 2.8647. It goes on, and we make it to 1 decimal place. That will be 2.9 centimeters to 1 decimal place. Notice once again, because we are looking at the length of the radius, so we just make it to be in centimeters rather than in centimeters squared. Okay, question 4. It says what is the area of the sector AOB. We have this sector right here, as you can see the shaded portion. I want to find the area of these parts of the circle. So that would be, we know the angle that is obtained. So the angle out of 360 multiplied by the area of a circle. So area of a sector is equal to theta over 360 times pi r squared. The angle, which is theta, is 120 degrees. So we divide that by 360 multiplied by pi and the square of r, which is 4. And if we press our calculators, our answers will be 16.755. It goes on and on. And then we approximate to one decimal place. You have 16.8 centimeters squared. So one decimal place. And notice it is centimeters squared. And the reason is because we are trying to find the area, and area is usually in centimeters squared. Let's go to question 5. And question 5 tells us that we are to find the value of x in this diagram below. Now, if you look at this diagram, we have a chord, this chord right here, and we have these radii right here, 6 meters. Then we have a length from the middle of the circle to the chord, which is labeled x centimeters. And something else that we should note as well is the fact that the length of the chord is 10. And a line from the center of the circle, bisects the chord into 2 equal parts. So this part right here would be 5, and the other part right there would be 5. Of course, it's a perpendicular bisector. You have a good 90 degrees here. Now, this diagram has shown us that the radius is 6 centimeters, or 6 meters rather. It means that I could actually redraw this diagram to be like this. You wonder why? The reason is because the radii is the same in any direction that you draw it. You remember that? That was one of the first things that we discussed. Okay, so if you have a radius from here to this part of the circumference, it is the same thing as if you had the radius from here to this part of the circumference, because it will be the same length, and every single radii in these circle is equal. Okay, so I could just bring it down like this, and then I have a right angled triangle. Now let me show you a prepared solution for this particular example. I want you to take a moment to study it, see if you can figure out what was done right there. Can you figure out what we did? Of course, it is Pythagoras theorem. And the reason we use Pythagoras theorem is because what we have right here is a right angled triangle. You remember your trigonometry? We said that when you have a right angled triangle, if you have 2 sides and you want to find a third side, then you make use of Pythagoras theorem. And notice that right here, the base here, or the shorter side, is 5 meters. And the reason is because this straight line here divided the chord into 2 equal parts. So you have 5 here and 5 there. So we just use this part alone. This would be the other side, and we just get that. Final answer is 3.3 meters to 1 decimal place. I expect that you all have a good understanding of that. Okay, so that would be all for the examples that I have for you today. I'll give you exercises, and they come now. All right, this the first 3 exercises. The first one asks that you should find the radius of the circle. So you're given the area of that sector, and then you are given the angle that is obtained. You have to find the radius of the circle. Okay, question 2 says, what is the length of the arc AB in the diagram below? So you have to find the length of the arc. You're given the radius, you're given the area of the sector, so that's not difficult to find. Okay, the third one, find the arc length and the area of the sector to 3 significant figures. Okay, so you have to find the length of the arc, okay, which is okay. Let me not bother to give you clues. I'm sure you should be able to find your way around it. And then you have to find the area of the sector as well. Okay, and then question 4 says that you should calculate the total perimeter, don't forget that, of the sector in the following diagram. All right, so you're given the radius and you're given the angle, and you have to find the perimeter. of the sector. I'd like to see what you do on that. Number 5, if the area of the sector below is 160 meters squared, find the value of x. Alright, I'm sure you can do that. Then number 6 says the diagram below shows a circle with center O and radius 10. And then it says you should calculate the area of the shaded segment. Okay, you have to calculate the area of the shaded segment. So you remember your formula for area of your segment. Just use that and then get your answer. Okay, like you always do, send your answers to the emails on your screen, and I would expect it in earnest. Make sure you do it as soon as possible. Okay, and then I'll correspond back to you so that I'll have an idea where you are as regards this concept and how we can move forward from there. Okay, so do have a wonderful time. Thank you for joining me today. Okay, bye bye.